discussing graphing of trig functions, primarily sine and cosine. What you're looking at on the screen right now is simply a basic graph of sine. Okay, now sine has a couple of properties that we want to make sure that we recognize. Being able to graph sine of x is important. There's a few things we have to remember. We have to remember where the sine graph begins. It begins at the origin. We have to remember that it has an amplitude of 1. So we also remember that the x-intercepts are at the whole pi's, really. So you have 0 pi, you have 1 pi, you can see here that's 3.14, and then of course you have out here at 2 pi at 6.28, and of course it goes backwards as well. Sine is an odd function, so you can see as it goes back across the y-axis, it kind of continues that pattern. We also want to look at cosine of x, the differences. If you look at the graph, and we'll change it to cosine, cosine begins at 1 at its maximum. It comes down through 1/2 pi, that's 1.57, and then it goes down at its minimum halfway through its period, which is 1 pi, or 3.14, and of course it goes back up through 3/2 pi, and it concludes back at its maximum at 6.28, or 2 pi. Now these are just the basic principles, basic properties of sine and cosine. If you're going to be able to graph this by hand, it is absolutely critical that you be able to graph those important or critical points, especially when we get into something a little more complicated, when we begin to change the amplitude, change the phase shift, change the period, the vertical shift, whatever those things happen to be. If I can't graph sine and cosine of x, there's no way I'm going to be able to graph anything more complicated. Okay, so for example, if you're looking at the bottom, we have a tab which is labeled a sine of kx plus c plus h. Okay, and if I just picked a particular example, this is 2 sine of 2x minus pi over 2 minus 3. And you can see the x-axis is up here. There's a negative shift in the vertical, I guess the vertical shift would be down 3. So you can see here the midline is now at -3. The amplitude is 2, so from -3 we go up 2 units, and we go down 2 units. Finding the period and the phase shift is going to be something a little bit different. You can see here that sine normally starts at its midline. If you go back and look at sine of x, it starts right at its midline, which in this case is 0, starts right at the origin. But when we look at this one, it starts at its minimum on its period. And so you can say, well, this looks kind of like the negative cosine. Okay, if you remember your cofunctions, anytime I subtract or add pi over 2, it's going to do that. So anyway, what we're going to do is we're going to attempt to graph these functions